Welcome to our journey of transforming Mars into a second Earth within the next 100 years. For centuries, humanity has gazed upon the red planet with a mix of wonder and longing, dreaming of the day we might set foot on its dusty surface. Today, that dream is within reach, and we're not just talking about planting a flag, we're talking about a complete planetary makeover. With SpaceX's Starship and groundbreaking technologies, this ambitious vision might just become a reality. Imagine a future where Mars is no longer a desolate wasteland but a thriving world, teeming with life and opportunity. Over the next hour, we'll delve into the science, the engineering, and the sheer audacity of terraforming Mars. Fasten your seatbelts, space fans, because we're about to embark on the ultimate cosmic construction project. First things first, if we're serious about turning Mars into a second home, we need to talk logistics. Getting to Mars is hard, staying there is even harder, and transforming the planet, well, that's a whole other level of cosmic challenge. That's where SpaceX's Starship comes in. A game changer in space travel and the linchpin of our terraforming plan. Picture this, a fleet of starships, these sleek, reusable spacecraft soaring through the cosmos, each carrying over 100 tons of cargo. We're talking about a continuous convoy shuttling between Earth and Mars, delivering everything from prefabricated habitats and laboratories to heavy construction equipment, and of course the pioneers who will be the first Martian colonists. By 2040 we envision a bustling Martian outpost, a testament to human ingenuity. Think of it as the ultimate off-world construction site. We'll need to establish power grids, build life support systems, and create the infrastructure to sustain a growing population. This is about more than just survival. It's about laying the foundation for a thriving Martian civilization. Mars has resources of its own. Water ice locked beneath the surface, minerals in the soil, and even potential sources of geothermal energy. Our Martian pioneers will be tasked with harnessing these resources, becoming a self-sustaining colony and reducing our reliance on Earth. Imagine robots working tirelessly alongside human crews, 3D printing structures from Martian regolith, the very dust beneath their feet. We'll need to develop new technologies, adapt to the challenges of a low-gravity environment, and find innovative solutions for everything from waste disposal to food production. But the challenges are not insurmountable. Remember, humanity has a knack for achieving the seemingly impossible. Terraforming Mars is a monumental task, but with Starship as our workhorse, we're off to a running start. By establishing a foothold on Mars, we're taking a giant leap towards becoming a multi-planetary species. The Starship Armada is just the first step in a journey that will span generations. Mars lost its magnetic field billions of years ago, leaving it exposed to space. Our plan? A constellation of satellites creating an artificial magnetic field. This shield will protect Mars, making it safer for human exploration. It will also help Mars rebuild its atmosphere, leading to a warmer planet. By 2045, we aim to have the first phase operational, transforming Mars for future generations. Okay, we've talked about getting to Mars and shielding it from harmful radiation. Now, let's address the elephant in the room, or rather, the freezer in the solar system. Mars is cold, really cold. With an average surface temperature of about -80 degrees Fahrenheit, it makes Antarctica look like a tropical getaway. So how do we warm up a planet that's been in a deep freeze for billions of years? The answer lies in a bit of planetary manipulation, specifically by harnessing the power of greenhouse gases. Now, before you start picturing giant factories spewing out pollution, let's be clear, we're talking about a controlled and calculated release of potent greenhouse gases, strategically chosen to maximize their warming effect on Mars. Think of it as giving Mars a little nudge in the right direction, a jumpstart to its climate system. We'll be targeting gases like methane and carbon dioxide, both of which are excellent at trapping heat. These gases will act like a thermal blanket, absorbing sunlight and preventing heat from escaping back into space. Now, where do we get all these greenhouse gases? Well, some of them are already locked away on Mars itself. Remember those polar ice caps we talked about? They contain frozen carbon dioxide that, when released, could significantly thicken the Martian atmosphere and contribute to warming the planet. But we're not stopping there. Remember those Starship fleets we mentioned earlier? Well, they'll also be carrying specialized payloads designed to produce greenhouse gases on an industrial scale. We're talking about automated factories, powered by Martian resources, churning out the gases needed to tip the scales in favor of a warmer, more hospitable Mars. By the 2050s, these combined efforts will start to show a noticeable impact. All right, we've talked about shielding Mars, warming it up and thickening its atmosphere. Now let's get to the heart of terraforming, introducing life. And not just any life, we're talking about the pioneers of our planet, the organisms that paved the way for all other life forms, Cyanobacteria. You might know them as blue-green algae, but don't let the name fool you. These microscopic powerhouses are photosynthetic masters, using sunlight to convert carbon dioxide into oxygen. Yes, the very oxygen we breathe. They were instrumental in transforming Earth's early atmosphere, paving the way for the evolution of more complex life forms. Now we're going to enlist their help in doing the same for Mars. Starting in the 2060s, we'll be sending genetically engineered cyanobacteria to their new Martian home. These aren't your average pond scum. They've been specifically modified to thrive in the Martian environment, able to withstand the harsh radiation, low temperatures, and thin atmosphere. Think of it as giving evolution a helping hand. These microscopic terraformers will be deployed in stages, starting with the most resilient strains. They'll be introduced to carefully selected locations on Mars, places where they'll have access to sunlight, water ice, and the nutrients they need to flourish. As they multiply and spread, these tiny oxygen factories will begin to work their magic, slowly but surely converting the carbon dioxide-rich Martian atmosphere into something more breathable for humans. It's a long game, folks, but over time, the cumulative effect of trillions upon trillions of cyanobacteria will start to make a difference. But it's not just about the oxygen. Cyanobacteria also play a vital role in soil formation. As they colonize the Martian regolith, they'll help break down rocks and minerals, releasing nutrients and creating a more fertile substrate for future plant life. We've covered shielding Mars, warming its atmosphere, and introducing life. Now let's dive into the heart of the planet itself, where we'll tap into a source of heat that's been dormant for billions of years. Volcanic magma chambers. You see, Mars isn't just cold on the surface, it's also geologically inactive, meaning its core has cooled down over time. And while that makes for a less volatile planet in terms of earthquakes and volcanic eruptions, it also means there's not a lot of internal heat radiating outward to keep things toasty. But fear not, intrepid terraformers, because we have a plan. Remember those massive nuclear reactors we've been developing for clean energy on Earth? Well, we're going to put them to good use on Mars, but not just for generating power. We're going to use them to jumpstart Mars's internal furnace, or at least a localized version of it. The plan is audacious, to say the least. We'll be drilling deep into the Martian crust, targeting areas where we know magma chambers lie dormant. Once we reach these chambers, we'll carefully position our nuclear reactors and let them do what they do best. Generate heat, and lots of it. Now, we're not talking about blowing up Mars from the inside out. This is a controlled release of energy, designed to slowly and steadily melt the surrounding rock and reignite volcanic activity in a localized area. Think of it as giving Mars a hot stone massage, but on a planetary scale. So why go through all this trouble? Well, melting these subsurface regions will have a number of beneficial effects. First, it will release trapped water and gases, further thickening the atmosphere and contributing to the warming effect. Second, it will create subsurface lakes and rivers, providing a potential habitat for aquatic life and a source of water for future Martian settlements. By 2125, Mars could be a transformed world, with temperatures around 0 degrees Fahrenheit, a denser atmosphere, and the beginnings of a living ecosystem. Imagine standing on the shores of a Martian lake, gazing up at a sky no longer red but a pale blue, a testament to the resilience of life and the boundless ambition of humanity. The terraforming of Mars is not just a scientific endeavor, it's a story that will unfold over generations, a testament to our ingenuity, our determination, and our enduring fascination with the cosmos. It's a story that challenges us to push the boundaries of what's possible, to become caretakers of not just our own planet, but of others as well. Stay tuned as we continue to explore the incredible possibilities of terraforming Mars. The future is out there, waiting to be written, and it's up to us to make it happen.